day 10. So we're multiplying radicals. Now, I don't want you to freak out because of the radical, because all the multiplication rules that we've learned apply. So that hasn't changed. So we're going to use the same rules, with just a little bit extra. So first off, you always want to have the radicals in simplest form. You always want them reduced. If you multiply them before they're reduced, you're going to end up with two numbers that are going to be difficult to reduce. So you want to reduce them first. Multiply the outsides, if applicable. Those are the coefficients. The numbers in front of the radical. Just like the numbers in front of a variable. Then multiply the insides, which is the radicand. And then you still have to check to make sure it can't simplify some more. So even though you simplify at the beginning, sometimes after multiplying, you end up with another number that can be simplified underneath. So you always got to check for that. Now, this first one is a perfect example of why we simplify first. 64 times 36. That equals the square root of 2,304. Anybody have an idea off the bat what that is? Probably not. Yeah, type the calculator, but it does end up being a perfect square, but off the top, it's like, that's a huge number. But if we simplify first, what is the square root of 64? It's just simply 8. What's the square root of 36? 6. And yes, this is the same thing, 48. But if you simplify it first, it's much easier. Okay, the next one. We're going to simplify this first. Okay? 12 breaks down 4 and 3. Right? Okay? 4 times 3. 4 is a perfect square. Square root of 4 is basically just what? 2. And this square root of 4 is 2. So we have 2 times square root of 3 times 2, which simplifies to 4 square root of 3. Keep the numbers smaller, they're easier to deal with. Now, we cannot simplify 6. Radical 6 does not break down. There is no perfect square number that goes into 6. The only perfect square number less than 6 is 4. 4 does not go into 6 evenly. So we can't break it down. So we're just going to multiply. Like I said in the notes above, we're going to do the outside times the outside, coefficient times the coefficient, and the inside times the inside. Radicand times radicand. So simply, like I said, the rules stay the same. Negative 2 times negative 3 is positive 6. I want to do this two ways. Now, radical 6 times radical 6 is technically radical 36. So what? What? Yeah, that's what I'm saying. That's what I'm showing you two ways. Some people need to process it step by step and do 6 times 6 is 36, and the square root of 36 is simply just 6. But we've talked about this before. You can just go directly there. A radical times itself gets rid of the radical. So radical 9 times radical 9 is just simply 9. Radical 35 times radical 35 is just simply 35. Radical 1,535,378 times itself is that. Okay? The radical goes away. So therefore, we can go just to this. But if your brain needs to process it step by step and go from here to here to here, that's fine. Nothing wrong with it. 36 is the answer. Okay. Outside times outside. Again, you can't simplify 2 or 6 underneath the radical. That's a negative 6. Inside times inside is radical 12. Do not stop there. Always ask yourself, can we break down 12? Yeah, we can. Right? So now the 12 is going to break down to radical 4 and radical 3. Don't forget about this 6. Negative 6 here. Okay, bring it down with you. Or circle it to remind yourself, or something. Draw an arrow. Remind yourself that it's going to be part of the next step. So we're at negative 6 times 2, radical 3. And then again, outside numbers, simply negative 12, radical 3. Now we're going to do with variables. Here's what I was talking about before. The rules don't change. Forget the radicals. What's x times x? X to the 1, x to the 1 is x squared. And guess what? Radical x times radical x is just simply radical x squared. The same multiplication rules apply. Nothing new. Except now we have to go one extra step and simplify. And we talked previously about pairs, remember? Or simple division problem. That's a 2 out there. We do 2 divided by 2, we get 1. Okay? Or if we think about even simpler rule, didn't we say radical 7 times radical 7 was just 7? Right? So radical x times radical x is just x. A radical times itself makes the radical disappear. Okay? A little more work over here. We do the outside first. Negative 6. Now we're going to do the radical. Well, we're going to treat the radical. Forget about, the radical. Just treat it like we know. This is really a 1 here, right? Yeah. So it's 1 times 4. The 4 just is there. And then x to the 3, x to the 5, go back to what we know, just simply x to the 3, x to the 5 is x to the 8. So that's just an x to the 8 underneath the radical. It's the same thing, just where is it? It's in the house. Okay? Now, we have a couple things to do. There's a 2 out here. The negative 6 stays. But what is the square root of 4? 2. And then, 8 divided by 2 is 4. And there's nothing left inside. Except negative 12, x to the 4, that's our final answer. Everything came out. Now remember, if that was x to the 9, it would still be 4 on the outside, but we'd have one x underneath stuck inside. Okay, same rules we've been doing. Remind ourselves that's a 1. If the radical wasn't there, this would be x to the 6th, y to the 6th. It's still x to the 6th, y to the 6th. It's just under a radical, which has a little 2 out here, which is going to help us with our division. Now remember, we can think about 2 ways. How many pairs are there in 6? 2, 4, 6, 3 pair. Or we can simply do 6 divided by 2. 3. 6 divided by 2. 3. And we're done. Now over here we have numbers underneath also. No big deal. We simply do 6 times 3. Because 6 and 3 won't break down. 18. X to the 3, x to the 1 is x to the 4. Y to the 3, y to the 4 is y to the 7. Ooh, we're going to have some leftovers. So we've got an odd number. If it's even, they all come out. If it's odd, something stays behind. Now, 18. does simplify. We use our chart and find out that 9 goes into it. 9 is a perfect square. So the square root of 9 is 3. I'm going to leave a space and put my radical because I got to remember that 2 is still stuck inside. My x's, x 4 divided by 2 is 2. So 2 pairs come out. And then 7 divided by 2 is 3. And then 1 stays back inside. And remember, if it's hard for you to do that whole division with the odd, then just do 7 wides. 2, 4, 6, 7. And go 1, 2, 3 pair with 1 left over. You can always go back to that. Okay? You don't have to just guess. You can always just draw it out. This one is silly easy. I'm just going to move that in front. That's it. Okay? It's just a coefficient. We always have the coefficients in front. But radical 2 times 5, radical 2 can't simplify. That's it. Okay? So here, negative 5 has only 1 out here to multiply by, so outside times outside is still negative 5. Inside times inside, radical 6, which will not break down. Again, there's no perfect square that goes into 6. This is just a basic distribution problem. So think about it. If I had 15 times x plus y, 15x plus 15y. Simple distribution. I want you to see the connection of what you already know. So 15 times 5 is just, radical 15 times 5, we put the 5 in front. We always just put the 5 in front of the radical. And 15 can't break down. 4 doesn't go into it, 9 doesn't go into it. Plus, just like over here, still plus problem. 15 times 3 is 45. So radical 15 times radical 3 is radical 45. This breaks down because there is a 9 trapped inside. So basically what we're left with is 5 radical 15 plus 3 radical 5. And we cannot join these together because they have different radicals. That's like saying 15x plus 3y. That's it, you're done. You cannot simplify any further. These are both inside numbers. So radical 2 times radical 5 is radical 10. Plus 10 times 5 is 50, so radical 10, radical 5, radical 50. But we're not done because there's a perfect square stuck inside the 50. And that will be 25. And 2. 10 doesn't break down, so it's radical 10. Plus 5, radical 2. And we're done. Can't do anything else. You're not joining them together. Now, woo! We got inside, outside distribution, everything going on. So we're going to multiply this here and this here. But when we do that, remember, the 3 and the 5 multiply, and the 2 and the 3 multiply. Radical 2, radical 3. So outside times outside is going to be 15. Radical 2, radical 3 gives me radical 6. Again, the 3 and the 6 are going to multiply, and the radical 2 and the radical 2 are going to multiply. So 6 times 3, the plus sign stays, 18. Radical 2 and radical 2 is radical 4, or if you just want to go to that rule, radical times itself is just straight up 2, that's fine. You can think about it either way, whatever works for you. You can go right to the 2, or do radical 4, then 2. So that gives me 15 plus radical 6. Ooh, no. 15 radical 6. Got a little ahead of myself there. 15 radical 6 plus 36. And the last one is almost exactly like this, but let's just throw in some negatives for the heck of it. So we're going to distribute and distribute. Outside times outside, negative 15. Inside times inside, radical 6. The minus stays. Except, this is really a minus 1, right? And we're multiplying by a minus 5. So negative times negative becomes positive. And it's just going to be 5. And then radical 3 times itself is just 3. Or if you need to do it, radical 9. And then you just finish it up. Clean it up. Radical 6 plus